Hello. Hello everyone, welcome. Can you hear me? Okay, just we're waiting 1 minute, then we'll start. Okay. Okay, thank you. Okay, so we will start today's session. So first of all, hello everyone, welcome. Welcome to the 7 days online training program on Google Earth Engine. So basically in this online training program, I will try to focus for beginners who don't have any knowledge about the coding, mainly Python or JavaScript. And first of all, I will try to teach you programming language. Okay, then I just jump on the Google Earth Engine and how we can use the different types of satellite images for the different types of remote sensing and GIS application we try to check. Okay, so first of all, simply introduce one by one, then we'll start our today's session. Okay, and basically each day I will provide you total 4 hours. 3 hours I delivered the lecture and 1 hours for the problem solving class. Okay, in the problem solving class you can easily share your own screen and show me your problem. Further we discuss about the solution. Okay, so kindly introduce one by one, then we'll start, please.
Hello, sir.
Hello. Yes, please.
Can you hear me?
Yeah, I can hear you, please.
First of all, thank you very much, sir, for providing such a great platform to learn about Google Earth Engine. And secondly, I'm Amjad Ali Khan from Pakistan. And currently, I'm in China doing my PhD in physical geography. In this program, I'm doing some remote sensing techniques using like NDVI, NDWI, land use and land cover. But due to its necessity, so today I'm joining this online session. So thank you, sir.
Okay, thank you. I hope everything will be completed and you learn more, inshallah. Okay, so next, please.
Inshallah, inshallah.
Good evening, sir.
Yeah, good evening.
Good evening, everybody. I am Mohammed Mainul Sheikh. I am from India. I have obtained my PhD degree from Aligarh Muslim University, India. Currently, I am working as research assistant. Thank you, sir.
Okay, thank you. Yeah, next, please.
Hello, assalamu alaikum everyone.
Walaikum assalam.
This is Mohammed from Bangladesh. I have just recently completed my bachelor degree from the University of Engineering and Technology, and currently I am serving as a lecturer at Bangladesh Army University of Science and Technology. So I have joined this session to learn remote sensing and GIS techniques so that I can implement this to write journal papers and so on. And I basically want to pursue higher studies, so this is why I'm joining this session. So hope to get along with you all. Thank you.
Okay, thank you. Yeah. Yeah, next, please.
Good evening, sir.
Yeah, good evening.
Thank you for very much for visiting on Google Earth Engine. I am Sangay Umar. I live in the Ivory Coast. I am student, but my English is not very good.
Okay, no problem. If you face any problem or any confusion, anytime you can ask me. I will try to again explain. No problem. Try to explain all of this.
Okay.
Okay, so let's go start today's session. Let me share my screen. So first of all, I will try to explain about our full syllabus. Okay, so after completing the 7 days online training program, what you learn. So then I jump our first class. So let me share my screen. Okay, can you see my screen? Is it visible?
Yeah, it's visible.
Okay, thank you. So let's go.
Yeah, it's visible. Yes, it's visible. Yes.
So first of all, this is the online training program for the beginners who don't have any knowledge about the coding. So a lot of people, they're thinking about the code is very hard, so that's why they don't try to use the Google Earth Engine. So they are use the different types of traditional GIS software, but which is not complicated for when you work with the big GIS special data analysis. Okay, so that's why in this time we just launched this online training program. Who don't have any knowledge, suppose you totally zero knowledge about the coding, okay, don't worry about that. So I will try to step by step, I will try to learn you all of those from beginners to advanced level. And our main target, you are become a developer of Google Earth Engine. Okay, and when you become a developer on Google Earth Engine, then I hope you can easily develop any kinds of algorithm in Google Earth Engine for the different types of remote sensing work. Okay, so this is our main target, to all of you just become a developer, and further you can easily develop any kinds of algorithm, any kinds of method for the different types of method in remote sensing were used for the different purpose. So you can easily develop any kinds of method, any kinds of algorithm in Google Earth Engine, and further you can easily do different types of analysis. Okay, so don't worry if you have no knowledge about the coding. So I hope you can easily learn all of those from beginners to advanced level. So in this online training program, basically each day I will provide you the 4 hours. 3 hours I deliver the lecture, 1 hour for your problem solving class. So problem solving class, every class I just give you some assignment regarding this class. So you also try to do this type of assignment. Okay, when you face any problem or any confusion, do this type of assignment, then you can easily discuss in our problem solving class for the assignment solution. Or any problem, you can simply share your screen, then show me your problem, then we discuss about that. And first day, basically I discuss about that introduction to Google Earth Engine. So basically how Google Earth Engine works. So all of this I try to explain. Then how to create the environment to use the Google Earth Engine using JavaScript or Python API, how we can use the both programming language. So in this session, I try to teach you JavaScript and Python. So both of programming language, how we can use for Google Earth Engine for the different types of remote sensing analysis. We'll have to discuss about that. And if you have no knowledge about the JavaScript or Python, so that's why today's session will discuss about the some basic context about the JavaScript or Python. Then we discuss about the client and server object, how we can easily get the server on Earth Engine platform and execute our code. We also discuss and discuss about the importing raster or vector data. So different types of raster or vector data, how we can easily import in the Google Earth Engine or export from the Google Earth Engine. We'll discuss about that. And filtering attribute table, how we can easily filter any kinds of attribute table. We also discuss about that. And second day, mainly I discuss about that filtering and displaying the satellite images. So basically Google Earth Engine, it's provide lot of satellite images, not only for the Landsat, Sentinel, MODIS, it's provide a lot of satellite images. And different types of satellite, we can find out the different types of information. Okay, and different types of satellite image we also analyze and extract the different types of information. So this type of satellite image, it can be Landsat, Sentinel or MODIS, how we can easily filtering, displaying, and how we can easily create the satellite composite. Okay, how we can easily calculate the band combination. So if you have no idea about this type of thing, I will try to explain when I just show you the practical session, then you can get the idea. Then how to export the satellite imagery, different types of satellite imagery we can easily export for the different purpose. We'll also discuss about that. And how to import, filter, reduce, clip, and display the raster data in Google Earth Engine. We'll also discuss about that. And also time series chart of NDVI, how we can easily create the different types of time series chart, suppose monthly time series chart, annual time series chart. Okay, we'll also discuss about that. How to export different types of shape file from Google Earth Engine. Okay, just a minute. Okay. And each class I also give the recorded class also. You can easily get the recorded, no problem. Yeah. And third day, mainly we discuss about that calculating any indices in remote sensing. So basically in the remote sensing, we are using different types of indices, and this type of indices we can use to drive the different types of information. Suppose NDVI, NDWI, SAVI, EVI, VCI, TCI, lot of indices we are using in remote sensing. So this type of indices, how we can easily compute using Landsat or Sentinel imagery, we also discuss about that. Then we discuss about that filtering, displaying the Sentinel-2 satellite imagery and monitor the different types of indices, how we can easily extract the water body using the thresholding technique, and how we can easily create the different types of time series chart for the different types of indices. Okay, and how to export the shapefile or add the gradient legend. Okay, as well as we will discuss about the flood mapping, so how we can easily detect the flood water and permanent water. So this type of things we will discuss, and discuss about the monthly time series chart, different types of indices we will discuss. And fourth, they basically discuss about that satellite image, how we can easily remove different types of cloud and haze from our satellite image. So mainly when you work with rainy season, then you find out a lot of cloud on our satellite images. So this type of cloud or haze we can easily remove from Google Earth Engine. We can easily remove, okay, from here. And then we'll discuss about the DEM data. DEM data basically is digital elevation model data. It can be NASA SRTM DEM or Aster DEM. So this type of DEM, how we can easily use to create the different types of topographical mapping, such as elevation map, how we can easily create the slope map or hill shade map. So this type of map, how we can easily create for the different types of topographical mapping, we also discuss about that. Then land surface temperature, how we can easily monitor LST, land surface temperature. Basically we are using the Landsat satellite imagery as well as also use the MODIS satellite imagery. So both of satellite image, how we can easily use, I also discuss about that. After that we also discuss about that urban heat island. So basically LST and urban heat island, this is the two topic related. So that's why let's discuss about that urban heat island, how we can easily monitor. And also impact of urban heat island, we discuss about the urban thermal field variance index. Okay, so how we can easily monitor, and how to make the LST time series chart or urban heat island time series chart or UTFBI time series chart. Same process, I'll also discuss about that. You can easily get the idea. And fifth number, they basically discuss about that air quality monitoring. So different types of air quality parameters such as nitrogen dioxide, sulfur dioxide, then methane, then carbon monoxide or nitrogen dioxide. So this type of gases, how we can trace using the satellite images, we also discuss about that. And how to download the air quality parameters time series data in CSV file format, we also discuss. And air quality monitoring time series chart, how we can create the temporal analysis, as well as how to calculate the total emission of any specific gases using Sentinel 5P satellite data. We also discuss about that, as well as we also discuss about that AOD, aerosol optical depth, how we can easily monitor, and also discuss about the particulate matter 2.5. Okay, and this type of map, how we can easily check the accuracy. Okay, we also discuss about the also accuracy, mainly R square value or root mean square error. So this type of thing we also discuss about that. And in this session, I will add the another tool, ArcMap, mainly ArcGIS. So basically from the Google Earth Engine, we are just downloading the data. Okay, so this data further we also need to use the mapping software, suppose ArcMap or QGIS software, to produce the map for our research paper. Okay, so then how we can create this type of map layout, we also discuss about this in this session, fifth number test. Then you can easily get the idea how to download the data. Same process for any data, same process for creation of map using ArcMap. So you can easily get the idea. Then discuss about the accuracy assessment of air quality monitoring. We also discuss about that. And discuss about that how to extract the point pixel value for a specific geolocation. Okay, just a minute, just a minute. Important message, just a minute. Okay, so let's go continue. So then we talk about the accuracy assessment of air quality monitoring, then how to extract the point pixel value. We also discuss about that, and how to check the trend analysis. Okay, suppose for a specific study area, nitrogen dioxide is increasing or decreasing day by day. We also discuss this type of trend also, and how to apply the linear regression model. Okay, and apply the different types of remote sensing analysis. We also discuss about that. And sixth number day basically discuss about that introduction to machine learning. Okay, introduction to machine learning, how we can really apply the machine learning in Google Earth Engine and create the different types of classification problem. Suppose land use land cover, then crop types classification, different types of classification problem, as well as we can also apply some different types of regression problem. We also use the machine learning. So I will try to show you this type of things, how can they apply the supervised, unsupervised algorithm to make the land use land cover, then random forest or cart or support vector machine or minimum distance. So this type of method, how we can really apply and make the land use land cover. After making the land use land cover, how we can really check the accuracy assessment of Google Earth Engine. Suppose kappa accuracy, producer accuracy, or consumer accuracy. So this type of accuracy, how we can really check, we also discuss. And how to add the calculate the class area, or then how to add the legend. Okay, how to export the land use land cover for your research paper. We also discuss about that. Then last number class we discuss about that change detection. Okay, it can be land use land cover change detection or NDVI change detection, NDVI classification, then how to extract the dense vegetation, then class wise land use land cover change detection, calculate the transition area. Okay, suppose how much water body convert into build up, how much vegetation convert into build up. So this type of transition, how we can really calculate, we also discuss about that. And then we talk about that another thing is the urban development, how we easily create the urban development or urban expansion mapping or urban spiral mapping. Okay, and how we can easily create the urban growth monitoring. So this type of things I also try to explain in the last number class. And hyper parameter turning or hyper parameter optimization, how we can easily use to improving our accuracy. Okay, we'll also discuss about that also. So this is the full syllabus of total 7 days online training program. And in this session, I try to show you with a lot of practical things. Okay. So this type of practical things further you can also modify and apply for the different remote sensing analysis. Okay. And every class I will give you some assignment in our Google Classroom. You can easily get all of those from our Google Classroom. So you try to do this type of assignment for your practice. Okay. For your practice, it will also help you to do this type of assignment. And after completing all of assignment, you also get the certificate. After submitting all of assignment, you can get the all of materials, mainly slide, PDF, or all of those material, practice code, or recorded session. After live session, you also get the recorded session. And then you also get about that a lifetime teaching support. So lifetime teaching support, I also clear about that. So regarding this online training program, suppose this type of content you don't understand, so you can get the any support. So as a beginners, we face a problem when you try to develop this type of method in your own study area. So you face some problem. Yeah, this problem is not much big, but it's very easy. We can easily get the solution. So you try this type of concept, try to apply on your study area, and when you face any problem, you can get the lifetime teaching support regarding this type of content. When you face any problem, okay, you can get the lifetime teaching support regarding this course content. And also research collaboration. So after completing the total 7 days online training program, if you are interested to publish any scientific paper, then we simply collaboration, and then further you also make the paper. Suppose some part I just make the analysis, some part you just make the analysis, and then make the collaborate and make the scientific paper also after completing the total 7 days online training program. Okay, so this is the total full syllabus, our total 7 days online training program. So let's go first days. We try to discuss. Let me open my slide. Just a minute. So let's continue. So first of all, we discuss about the introduction to Google Earth Engine. So basically, what is Google Earth Engine? Okay. So basically, Google Earth Engine, it's a totally cloud-based platform. Okay. So cloud-based platform for geospatial analysis. And every cloud-based platform have a common characteristic is that it has own server. Suppose if you think about the YouTube is one kind of cloud-based platform. So when you upload a photo or when you watching a movie on YouTube, so this you can upload this movie or you can watch the movie from YouTube server. Suppose when you upload a photo on Facebook, so this photo is uploaded on the Facebook server. Okay, so every cloud-based platform have a own server and everything will be controlled from this server. Same like as Google Earth Engine. Google Earth Engine, it's a totally cloud-based platform and all of those are controlled from the cloud. Okay, we don't need any kinds of downloading any kinds of data, we don't need to download any kinds of software, anything we don't need to download. So all of those we can easily get from the online environment. Okay, online environment where computing resources such as storage, then processing, then power, then software application are delivered over the internet. We can easily get all of those, not need any kinds of local computer, we don't need to use. We are just use the server, and every cloud-based platform have a own server. Google Earth Engine has a server, so from this server we can easily access lot of data set, we can easily get the lot of data set. Suppose 40 years of satellite imagery we can easily access from the Google Earth Engine data catalog. Okay, so we don't need to download any kinds of data from other sources. Okay, sometimes we also need, but maximum time we don't need to download any kinds of satellite data, any kinds of anything we don't need to download from the other site, because from the Google Earth Engine server we can easily access all of dataset. So this is the big opportunity to use the cloud-based platform. So when you are using the cloud-based platform, we don't need to download any kinds of data, any kinds of software, we don't need to download, because everything will be controlled on the web server. And in the Google Earth Engine we can easily access 40 years of satellite imagery, as well as suppose I need some special data in remote sensing where use some high resolution imagery. So this type of imagery is not available in the Google Earth Engine. Suppose a sport satellite imagery or any kinds of drone imagery. Okay, suppose you have some drone imagery, so this type of drone imagery you want to upload on Google Earth Engine also, and further you can also use the Google Earth Engine function. Okay, suppose you can simply monitor the crop growth or crop health monitoring using a drone imagery. So this drone imagery you can easily upload on Google Earth Engine, and then you can easily use the Google Earth Engine function. Okay, not only for that, some high resolution satellite imagery, suppose a sport satellite imagery or maxar satellite imagery. So this type of high resolution satellite imagery we can easily upload on Google Earth Engine, and further we can easily do different types of analysis. So this is the another opportunity, because in the Google Earth Engine it's not provided with some commercial software, commercial satellite data is not provided. Okay, suppose a sport satellite is it's one kind of commercial satellite, or also maxar is one kind of commercial satellite. Okay, or drone imagery or lidar data. So this type of data we can easily generate from outside, and further we can also upload on the Google Earth Engine, and we can easily use the different types of Google Earth Engine function and make the analysis. So this is the another opportunity to use the Google Earth Engine, and we can apply the different types of algorithm in our data, and finally we can easily export the image, we can easily export the chart, we can easily export the map output, anything we can easily export from the Google Earth Engine. So this is the overall view of Google Earth Engine. It's a totally cloud-based platform, and everything will be controlled from the cloud, and every cloud-based platform have their own server, and everything will be controlled from this server. We don't need to download any kinds of data. We can easily access all of freely satellite data in Google Earth Engine data catalog. But we can also upload our own data set. Suppose some high resolution imagery. It can be drone imagery, it can be your sport satellite imagery, maxar satellite imagery, or different types of commercial satellite imagery we can easily upload in the Google Earth Engine. And further we also make the different types of algorithm And finally, we can easily export image, table, chart, or map output. We can easily export. So this is the overall summary. I hope you can easily get the idea what is Google Earth Engine. Anyone any question about this slide? You can ask me again. Any topic or any question about this slide, you can ask me. Anyone any question about this slide? I hope everything, if the everything is good, simply you can make the chat in the good, or any confusion, then I can easily understand that things. You can get the understanding about the Google Earth Engine. Okay, just make a message, okay, for the confirmation. Okay, or any confusion or any question about that, you can also ask me, no problem. Okay, everything is good or not for this slide?
Yes, it's good.
Okay, thank you.
No questions.
Okay, thank you. We are just make the interactive session, then it will be more better. Okay, so let's go. So now application. Okay, there are the lot of application. We can include in the Google Earth Engine, and day by day, different types of developer, they can add the different types of application. Okay, and we can easily use the different types of application. Just we need to know about the algorithm. Okay, suppose we can easily do for detecting the deforestation. It's one kind of application of remote sensing. Then classifying land use, land cover, then estimating forest biomass and carbon, then mapping the world's roadless areas, then assessment of the plant health status, then air quality monitoring, water quality monitoring, flood mapping, damage assessment, drought monitoring, burn severity mapping, and so on. And also LST monitoring. So here I include some application, but it's not, we can add any kinds of application, okay, in remote sensing in Google Earth Engine, easily do than other software, just ArcMap or QGIS software. Okay, we can easily do any kinds of application. So here I include some, but not only for that, any kinds of application you can easily develop using Google Earth Engine. And cloud-based platform, basically in Google Earth Engine, we freely use 250 gigabyte. Okay, 250 gigabyte data. I can easily store it in the cloud freely, 250 gigabyte. But further, this type of data we can easily remove, and we also get the new space. Okay, as well as Google Earth Engine now is also used for the commercial. So in the commercial, we can also buy some cloud storage, okay, from the Google Earth Engine. Further, we can also use it, but freely we can get the 250 gigabyte data. We can easily upload on the Google Earth Engine, but it huge. Suppose your work is completed for this data, simply remove, then we also find out the new space again. Okay, so now Google Earth Engine focused on society's biggest challenges, such as deforestation, then drought, then also climate change, then disaster, then diseases, then global food security, then sustainability. So it's mainly focused on the society's biggest challenges on Google Earth Engine and solve this type of challenges. And why this is important at the present time? So I think here all of you already use some basic GIS software, ArcMap or QGIS software or NV software. So this type of software have a common limitation, is that we don't process the big geospatial data analysis. Suppose I want to make the land use land cover map for the whole world, or I want to make the vegetation analysis for the whole world, then it take a lot of time. Okay, first of all, we need to download the data from satellite data, then we need to process this satellite data, then further we need to import in the ArcGIS, then apply the different types of correction, then apply. But in Google Earth Engine, we can easily do this type of analysis. Suppose for the whole world, I can easily make the land use land cover within 1 minute. For the whole world NDVI analysis, we can easily do very quickly. Okay, so first of all, it reduce your time to the analysis, and we can easily work with big geospatial data. Okay, any kinds of big geospatial data we can easily work with Google Earth Engine. Okay, very quickly we can easily access petabytes of data or more on the way. Okay, easily. And this Google's computing power is very fast. Okay, suppose I have total 20 years data or 40 years data. So within a 1 second we can compute it, the average, maximum, minimum, or any kinds of statistical things we can easily compute it very quickly. So this is the first opportunity, is that we can it reduce our time to the analysis. Okay, we can easily apply different types of algorithm, suppose supervised, unsupervised, regression, different types of algorithm we can easily apply. And this platform have some new feature. In Google Earth Engine we find out some new feature. So this type of feature, it help you to remove the cloud or haze from your satellite imagery. We can easily remove any kinds of satellite cloud or haze from our satellite image and get the very neat and clean satellite imagery. And then we can easily integrate with the big data or AI or machine learning. We can easily use, suppose Google Earth Engine integrate with the AI for land use, land cover, or change detection. We can easily do this type of things, as well as we can easily share our work. Suppose this is a cloud based platform, so that's why we can easily share our work, okay, globally. And it's a global accessibility. We can find out that from anywhere with the internet connection. Suppose anywhere, if you just need the internet connection. So if you have the internet connection, we can easily work with the Google Earth Engine and don't need any kinds of things. Suppose you can use the, suppose your PC is not much big, your PC RAM ROM is very low, don't worry about that. So you can simply run all of those in the cloud, don't need any kinds of software. Okay, so your computer configuration is doesn't matter when you're using the cloud based platform. Okay, just you need the internet connectivity, good internet connectivity you need. So here you're using the Google Earth Engine, but your computer configuration is not, doesn't matter in this case. And then it's mainly one kind of platform where we can do a global data analysis. We can easily get all of data globally. Further, we can easily compare the data or analyze the data easily. So this type of opportunity we can also use. So that's the region, it's very important present time. And what's the pros and cons of using the Google Earth Engine? So basically there are a lot of advantages to use the Google Earth Engine. First of all, you don't need to download any kinds of imagery. So if you are using the ArcMap or QGIS software, first of all, we need to download the satellite imagery, okay, from Earth Explorer or USGS website or different sources. We need to download the satellite imagery, okay. We need to download the satellite imagery, okay, from different sources, Earth Explorer or USGS website. We didn't need to download the satellite images. But in this case, we don't need to download any kinds of satellite imagery. Okay, we don't need to download any kinds of satellite imagery. So this is the one kind of big opportunity to use the Google Earth Engine. And we can easily access petabytes of data or more on the way. And Google computing is very fast. We can easily do a lot of data very fast, quickly analysis using this platform. And cons is that we need to some programming knowledge. Okay, not much big, some programming knowledge we need. But I also try to teach you all of those which you need to learn the Google Earth Engine. And it also differs on the internet connection. Okay, so if your internet connection is good, then we can easily get the very quickly that we can easily get. And primary focus on the raster based imagery. Okay, lack of mature detailed documentation. But in this online training program, I will try to provide you all of documentation, then you can easily get. Okay. Okay, just a minute. I think one participant is not joining. Just a minute. Just I give the permission, then start continue. Just a minute. So let's continue. Yeah. And how does the work? So basically Google Earth Engine, it is a totally cloud-based platform. So when I write any code, this code send a message to the Earth Engine server. Okay. In a matter of second, this server give you the response. Suppose I need the Landsat image. So just I write the code for Landsat image. Then this code send a message to the Earth Engine server. In a matter of second, this server give you the response, give you the Landsat image. Okay. So software type basically web processing or cloud computing, and every cloud computing platform have a own server, and everything will be controlled from the server. We already know about that. And then this is the main website about the earthengine.google.org, and accessibility must be online. Without online connection, we cannot use the Google Earth Engine. And requirement basically Google Earth Engine is free of charge, but now Google Earth Engine is also paid version is also available. Basically in the paid version we are just use here the deep learning. Okay, but freely we can easily use the machine learning. Okay, but when you apply the different types of deep learning, mainly convolution neural network, CNN, or artificial neural network, then we need to apply their commercial of Google Earth Engine. Okay, but for that we are just use here the freely sources. Okay, Python, basically Python have lot of package for applying the deep learning, Keras or TensorFlow. So this type of thing we can easily integrate with the Google Earth Engine freely. But anyone they can also buy the Google Earth Engine commercial, they can also use it. But freely we can use the machine learning in Google Earth Engine. And to use the code editor, we need to registration with the valid Google account. So I think here all of you already make the registration. Okay, registration is the complete or not? Anyone have complete the registration or not? Okay, simply if you complete the registration, simply write the yes. Okay, complete this registration or not? Okay, I'll also try to show you this process, no problem. Okay. Okay, so let's go. I'll try to show you this process also, how we can easily registration with the Google Earth Engine. So now they also add some restriction to use the Google Earth Engine. Basically all of users then they must be use the cloud project. Okay, but previous time it's not mandatory to use all of users. So now Google Earth Engine authority, they are all of users in Google Earth Engine, they must be use the cloud project, otherwise you cannot use the Google Earth Engine. So this cloud project we can easily create, no problem. I have to try to show you this process also. So competencies must be online. Then it's mainly work for the image processing or visualization, and it also work the raster and vector data. Both of that we can easily handle using the Google Earth Engine. Okay, so before that we also discuss about that how to open the Google Earth Engine code editor. So in this time, if you have already registration, then you can simply visit the link. So this is the link, code.earthengine.google.com. So you can simply visit this link, then you can easily access the code editor. So this is the code editor. Okay, so if you don't this type of registration, then first of all you need to make the registration. For the registration, simply click on the simply search Google Earth Engine, and then you can see the to register with for Google Earth Engine. Just click on here and simply give all of information. Okay, and then you can easily registration with the Google Earth Engine. So in this time here you can see I already create my project. So this is my project name. Okay, so then you can simply manage registration, click on here, and then simply you can create the project. Okay, basically now they are the new configuration, but previous time this type of configuration is not needed. Okay, but now they are also asked the different types of question why you're using the Google Earth engine. Okay, so you try to fill up all of question, and why you are using it's freely. Okay, this type of thing you try to put the answer step by step, then you can easily use. Or you can also just switch to commercial. Okay, then click the switch to commercial, then you can easily buy their cloud project or other things, or register a new cloud project. So here I already developed this cloud project, so this is my cloud project name. So you can also register if you don't have the account, so you try to click on the register a new cloud project, then simply choose paid or unpaid. Suppose you choose simply unpaid, then simply select the academia, or in just fill up all of information step by step, then you can easily make the Google Earth Engine code editor. So after completing the registration, simply go to this link. So this is the link. So when you go to this link, it's open this type of code editor interface. So this, it's called the JavaScript API code editor. Okay, so this code editor we can write only for JavaScript programming. Okay, this code editor, and this code editor is very powerful code editor, because all of those we can easily access from this code editor. So this code editor, we can easily access all of those. Okay, and it's called the JavaScript API code editor. But we can also run the Python also. Okay, in this training I will try to show you that JavaScript and Python, both of programming language. Then I hope we can easily get the idea how we can use the JavaScript and Python. And when you need the Python, when you need the JavaScript, you can also get the clear idea about that. So now we try to discuss about this user interface of this code editor. So basically this is the code editor, and in this code editor we can easily get, this is the map interactive view. Okay, so in this map we can easily get this type of map. Also click on the satellite, then we can get the satellite view map. Okay, and also you can see the zoom in, zoom out, also hand tool for moving the map. Also you can create the point, line, polygon, or rectangle. This type of feature we are used to create. And if you check the inspector tab, console tab, and tags tab, so an inspector tab basically used for map querying result. Suppose I add some map. Okay, so now I want to check for information from this map, so then we are just use here the inspector tab. Suppose in the example, suppose this is my one kind of previous work. Suppose for this work I add some different types of map. Okay, in this time you can see I add the cloud base height, cloud top height, cloud fraction, cloud top pressure, cloud optical thickness. So I add this type of map for my study area. So now I want to check the information. I want to check the information for a specific coordinate. So what can I do? So for that I simply click on the inspector tab and click. Suppose I just click on here. So now it show me the coordinate. You can see the latitude and longitude value. And for this latitude longitude value, what's the value for cloud optical thickness? What the value for cloud top pressure? What the value for cloud fraction? What top height? Cloud base height? So all of info I can get. So just click on here. So now for this coordinate, we also get the coordinate and also get all of information. So this is the inspector tab. Okay, suppose when you add any map, it can be NDVI map, any map. Just simply click on the inspector tab and check the map result for a specific geolocation, a specific coordinate. Okay, in this time there is no map. So now if I just click on here, so now it show about the latitude, longitude, and zoom level. Okay, so we find out this type of information. Suppose I just click on here, so now it show about the latitude, longitude, and zoom level for this specific location. But when you add the map, suppose this type of map, it can be NDVI map, NWI map, or any map. So now we need to check for this map information. Just click on this, then it automatically show you for this coordinate what's the value for each layer. Okay, so here I add 1 2 3 4 5 layer. So I find out the 5 layer information from the inspector tab. So when you add only for the one layer, then you can get only for the one information. So this is the inspector tab. We are just map querying result. So for the specific location, what's the value for map? We can easily get this type of pixel value from here. So now console tab. Console tab basically print your output. Suppose I simply print. So print is one kind of function. Suppose when I use the print, this function output always I find out under the console tab. Suppose I print this number 2025 and I run the code, run mainly execute your code. Just click on the run. we can get the result in the console tab. So print, when we apply the print, this output always we find out under the console tab. Okay, then tasks tab. Tasks tab basically managing your long running tasks. Suppose when you upload, when you export anything, then this tasks tab show you the progress of your exporting or importing result. You can see here I already export some file. So this file for exporting need the 1 minute, less than 1 minute, less than 1 minute, and also get some problem. You can see red alert sign. This means that your code have some problem. Okay, so this tasks tab mainly show you the progress for your exporting or importing any file. It can be raster file, it can be vector file, or it can be CSV file, anything. When you're exporting or importing, this tasks tab show you the progress, how much time you need, or is there any problem, then we find out the red alert sign, or if there is no problem, then we can get the right sign in here. Okay, this is a tasks tab. So I can get the idea about the inspector, console, and tasks. So now we talk about this side. If you check script tab, docs tab, asset tab, and AI tab. So now in the script tab, basically it manages your script which you save. So here you can see I already saved different types of script. So further, when I need this type of script, I simply click, it will be added in my code editor. So it's called the code editor. In the code editor, we can simply write our code or modify our code. Suppose you can see different types of script. Here I already saved. Suppose I need this script. Just I click. Then the script is added in my code editor. You can see. Okay, it added in my code editor. So further, when I run, I can get the result. Okay. So this is the script tab. Script tab basically manages your script which you save. So you can easily save different types of script, and further when I need the script for the future time, I can simply access from the script tab, and further I can modify this code, or we can easily do this type of things. So how I can save the code? Okay, if you check, this is a save button. Okay, so when I click on the save button, it will be saved under the script tab. So here I already save it. So you can see save as, put the name. Okay, put the name. You can put any name. Okay, file name, and then okay. Then it will be saved under the script tab. Okay, so script tab managing your script which you save. So further from here, when I need this any kinds of this, simply click on here, and yes, then this script is added in my code editor. So now from this code editor, I can easily run the code. You can easily get the result. Okay, so this is the process to add the save your script. Okay, we can easily save our script from the script tab. Okay, we can easily save. How I can save? Very easy. Just you can click on the save button and give a file name, then okay, then it will be saved under the script tab. Okay, so now docs tab. Docs tab basically it's the documentation. It provides you all of function documentation. Suppose click on here. So this is the heading ee.date. When I click on this, then we find out the all of sub function of heading ee.date, all of sub function for ee.date we find out, and click suppose a specific function, it show you the documentation as well, show you the argument about this function. So you can see ee.date, it's one kind of function. It mainly constructs a new date object. So when you need to create a new date object, then we need to use the function ee.date, and this function have a two argument, date and tz. What is the date? Date basically date, number, string, or computed object, or tz mainly string or optional. It's optional. Optional means that if you ignore this argument, there is no problem, but you must use it because it's not the optional. You must use it. So all of argument you can check and also get the description. Not only for that, any function you can easily check all of those. Suppose click on here, then click, you can see this is the one kind of function. So what is the tax about that? We can easily get from here. Okay, it created date range with the given start and end date. Okay, so start, in, and time zone. So you can simply define start, and in, and time zone. Then this function will be work. So now what is the start? What is the end? So this type of information you can see. What is the start? What is the end? What is the time zone? So you can easily get all of those. So this code editor, when you are using, you don't need to memorize anything. We can easily get all of those from docs tab. You can see the ee.feature, click on here, then you can see ee.feature, it's one kind of function. So this function can be constructed from the one of the following argument, plugs, optional, dictionary, or properties. Okay, we can easily include this type of file, geometry, GeoJSON, or GeoJSON feature. Okay, so this is the documentation tab. It's mainly help you all of documentation it's provide, and from that we can easily write our code in the code editor. So documentation is one kind of friend. When you face any problem, you can simply search in here this function and check the function documentation, and then further simply apply. Okay, then asset tab basically managing your asset which you uploaded. Okay, suppose here you can see here I already uploaded different types of file. Okay, suppose CSV file or shape file, or also some drone imagery I also uploaded in here. This is the drone imagery, it's high resolution. So this type of file, it's uploaded on your asset tab. Okay, and we can freely upload it 250 gigabyte in our asset tab, different types of data. It can be shape file, it can be CSV file, it can be drone imagery, it can be anything. We can easily upload it in the asset tab. Okay, how we can easily upload, after some time I also discuss about that. Then AI is basically, it's a new addition add in the Google Earth engine, just like as a chat GPT. Okay, or Gemini, we also use this type of AI. So it also working phase also. Okay, so now it also working. So after I think further it also added the chat GPT option in here, or also Google AI Studio, this type of feature we can also add it in the AI. Further anyone can easily ask the question, it automatically show you the map or other things we can easily get from here. Okay, but for use the AI we also need the some basic things about the Google Earth engine. Then we can easily modify the AI code, and then we can easily get our desired result. Okay, so after that, get link button. So now for how I want to share this code with you, so how I can share. So this share option is the get link. Click on the get link button. So now you can see it provide this type of link. So if I just copy and send you the code link, you can simply click on the code link, then this code is shared with you. So then you can easily get this type of result from here. Okay, so this is the process for the get link button. Get link button basically share your script. Click on the get link button and copy the link, then anyone can easily access this code. Then save button I already discussed about. The run button basically execute. Reset button, so when I click on the reset, it will be clear. You can see it will be clear, all of those clear. Another thing is the very important, it's called the apps. Google Earth engine is also another opportunity. We can create different types of application, different types of software we can easily develop using Google Earth engine. Okay, and this type of software or this type of app, anyone, any non-coder, they can easily use, and further they can get the result, or they can easily get the information. In this case I will show you some application. Suppose it's one kind of application. Okay, let me open it and show you that. Just click on here, it will be open, and anyone can easily go to this link and easily visit our web application. Suppose it's just show you the map. Okay, not any kinds of function in here, just display the map on our result. Suppose you can see it show this is our study area, and also show the satellite imagery. So anyone easily visit this link and they can easily display the result. Okay, they can easily show the result for the land use, land cover information we can easily get for this river side. So if you check, it show the water body, how much area water body, how much build up, how much agricultural land, how much vegetation, how much barren land. Okay, add the list and also add the map. Suppose you create this type of map and you want to share, you public your work. Okay, so simply copy the link and public your work, then anyone simply visit the link and they can easily show your work. So this is the opportunity to use the Google Earth engine. Not only for that, we can also use, suppose, some functional application. Suppose just I click on here, so it's one kind of functional web application. So this web application you can easily use and identify district wise land use, land cover for Bangladesh. Suppose it's one kind of interface of this software or application. So in this application, suppose I simply select a district. So you can see all of district available in this list. So I simply choose a specific district. Suppose I simply choose here for Jamalpur. Just choose it. So now you can see it automatically show you the land use, land cover map of Jamalpur, and also show you the statistical value, how much tree cover, how much cropland, how much barren land, how much water body. We can also download the data as a CSV. So it show for mainly present time, only present time or update data we can get from here. But when you work with the past time, then you need to develop the another application. Not only for the Jamalpur, so any other district. Suppose I need the result for Dhaka district, click on the Dhaka. So now it display the result for the Dhaka district boundary. We find out this is the Dhaka district boundary. This is the legend, all of land use, land cover legend, and how much tree cover, how much grassland, how much cropland, how much build up. So all of info you can easily get. Also download the data as a CSV file. Okay. So any district we can easily get. Just select, then it will be show you the result. We find out from here. So it's one kind of functional application. Not only for that, if you check others, suppose agriculture or drought monitoring. So this application help you to identify drought hazard. We can easily get the where is the extreme hazard, where we find out the low hazard. Okay. So if you check this is the agriculture drought in rain-fed and well area of the Sindh province. So this is a one kind of collaboration work with this university. So if you check it, suppose just click on here. So you simply choose. You can simply choose any district. Suppose I choose this one and choose the year. So different year I want to check. So this suppose 2020 I check. And then index. So drought is defined on the different types of index. Suppose precipitation index, vegetation index, temperature condition index, vegetation health index. I simply suppose BCI. So now then run the code. So now it automatically show you the result, drought hazard condition for this district. Okay, it's loading. So now you can see it show this type of result. I also show you the time series chart of the VCI and also display this type of for this study area. How you find out the extreme dry, severe dry, moderate, normal, and wet. We can easily get this type of result. So it's one kind of complex web application of Google Earth Engine. Okay, it's loading. In the minute, this is about the another one. So it's loading. Just a minute, I show the another one. Suppose another application, if you check. Okay, so you can also use the commercial software also. Suppose you can see here this type of software or application have a lock sign. Okay, lock sign, it means that it's not publicly available. But this type of I sign, it means that it's publicly available. So this type of application anyone can use from my developing site. They can easily use, anyone. They can easily use. But this type of software, it's not available. It's just for a specific person. Suppose it's one kind of subscription. If you get the subscription, then you can use this software. Okay, but this type of software don't need the subscription. So this type of option, suppose when you become a developer, you develop different types of commercial software. You can simply access this person who paid for this software. Okay, so this type of things is also possible to use the Google Earth Engine. Suppose I will show you this software. Just open it. So just I allow because just I use this email for. Okay, so basically it's one kind of water quality monitoring application we try to develop for the globally to identify water quality for a. So this is the user interface. Suppose for this water body, I want to check for the water body. Okay, so for that you can see we simply choose our time period. So start time. Suppose I put the time period in year of 2000. Suppose 23 January, 1st January. Suppose year of 2023. I take that December. I take the 1 year data. Suppose December 31. So I simply choose my start and end date, and further I simply draw my ROI, region of interest. Just I simply to click and draw my study area. So this is my study area. Okay, and further simply select a value. Suppose I need to compute the turbidity, chlorophyll, or total suspended solid. So I click on the turbidity and then submit. So now it creates this turbidity map for my study area, and also show you the you can this is the legend, and also show you that time series chart between this 1 year. Okay, when it will be high, when it will be low, you can easily get the idea from here, and it will also show some animation about that, as well as suppose I want to check about that chlorophyll and submit. So now it display about the chlorophyll map. So you can get the chlorophyll. So I want to check about the total suspended solid and submit. So we find out this type of result for the total suspended solid. Okay, and show about the time series chart. Okay, this chart you can also download. Click on here and download the chart data CSV file, download the photo. So you can easily get this type of information. Okay, and now it also developing phase also. We try to add the more item of the different types of water quality parameters such as BOD, COD or others. We can also try to add, and further it also we also use. So this type of opportunity is also available in the Google Earth Engine to develop different types of web application for drought monitoring, water quality monitoring, air quality monitoring, or anything. We can easily develop this type of things. Okay, and we can also use it for the publicly or commercially. Okay, commercially basically for a specific person who take the subscription, they can use it, and publicly anyone can easily visit this type of applications. Okay, so this is the apps tab. It's mainly managing your all of web application when you create. And further cloud project. Suppose in this case you can see it show the cloud project. This is my cloud project name. So if you don't have this type of name, it means that you are not create the cloud project yet. So for that, click on your icon and then you can see the register new cloud project. Click on here, or you can also visit from here. You can see the register a new cloud project also in here. The same, it find out the same website. Further, you can simply manage registration and put all of information. Okay, and then you can simply create the cloud project. Okay, put all of information, support what is your research question, what is your all of those, simply describe one by one, then you can easily get the cloud project and then you can easily use it. So in this case I find out this is my cloud project and this is the map interactive view, and this is a search bar. In the search bar we can easily search our data. Suppose I need the data, I simply search, so I suppose Modis data, simply search Modis NDVI. So then we can easily get all of Modis data, we can easily find out from here. Okay, and then I can easily use. And further, suppose I simply search on the place, simply search about Dhaka Bangladesh, simply search. So now it totally visit our study area easily. So this is the user interface of Google Earth Engine. Okay, so anyone any question about that, you can ask me for the user interface of Google Earth Engine.
Sir, how to delete a file from taskbar?
Okay, I'll show you that. So from the
Sir,
taskbar,
another query is,
yes, please.
what kind of data is saved in legacy asset?
Okay, so this taskbar, this type of information, it's automatically removed after 7 days. Okay, after 7 or the 10 days, this type of information is automatically removed. But when you remove the asset, suppose you can see when it will be successfully done, it means that it is stored in our asset tab. Okay, suppose you can see this type of file, I can simply click on here and then I can easily delete, then it will be removed from my asset tab. Okay, and this type of information, you can see it show the image one, this type of things, it automatically remove. And if you check, we find out the two types of asset. One type is the cloud asset, it's a cloud asset, you can see, as well as if you check it. So this is my cloud asset, so I create a lot of cloud asset, you can see, so all of my cloud asset. Also you can see this is the legacy asset. This legacy asset, it's not connect with our cloud. Okay, suppose when I use this type of thing file with my cloud, it's not work. Okay, so what is the cloud? Suppose when I use this file in my cloud Python environment, then it not work, this type of file. Your only this type of file, suppose this is my cloud asset, so all of are the cloud asset name, so only this type of file is work when I work with the Python environment, you connecting with the cloud project. Okay, but this type of legacy asset is only work for this code editor. You cannot use this type of asset on the other cloud based platform if we cannot use this type of things. Okay, So it's just your suppose local computer, local folder. Okay, legacy is one kind of local folder, and this is the cloud asset. And you can see it's this asset, different types of asset I created, and all of asset are active now. Okay, there is no problem. So it's all of the unpaid asset, unpaid cloud asset we create.
Sir, Google Earth Engine is a cloud-based platform. So, how long our research work is stored in this platform?
Okay, so we can suppose this type of file, suppose CSV file or this type of file, we can freely upload it 250 gigabyte. Okay, 250 GB we can upload it. Okay, so when you suppose your 50 GB is done, suppose it's completed, then we can simply remove our previous file and we can also get the new space again.
So, is it saved for lifetime or there is a time limitation?
There is no time limitation, only for memory limitation, 250 gigabyte freely. Okay.
Sir, I have another query. Suppose I'm working on this platform, do I need another software like QGIS?
Okay, yeah.
ArcGIS?
So yes, so we also need the ArcGIS software. Basically, if you check the research paper basically when you create the map layout, we just apply the ArcMap or QGIS software. Suppose I will show you some research paper, just a minute. So this type of map is generated by ArcMap. After downloading the data, we simply use the ArcMap or QGIS software. Suppose I will show you this. Suppose this paper. Suppose if you check this type of paper, this is the one kind of map. So this type of map we generate using Google Earth Engine. But you can see for the adding the legend, title or scale bar or title grid, all of those we are processing using the ArcMap. Okay, so these things I also show you that it's same process. You can also use the QGIS or ArcGIS or ArcMaps tool basically in the ArcGIS. Any kinds of map after downloading. Suppose you can see this type of map. Okay, land use land cover map. So it's created by Google Earth Engine. Okay, applying the random forest algorithm or support function algorithm. After we simply download the data as a GeoTIFF file format. It's a GeoTIFF file format. So this GeoTIFF file format file further analyze using ArcMap. Basically analyze, basically create the map layout. So ArcMap or QGIS software we are just used only for creating this type of layout for our research paper or presentation.
Only for layout?
Yes, only for the layout. Okay.
Thank you, sir.
And same process for any GeoTIFF file, apply the same process for creating the map layout, same process. So you can easily do it. In the 5th number class, initially I discuss about that, how we can easily use the ArcMap tool to creating this type of map after downloading the data from Google Earth Engine. Okay. Then you can easily get the idea. Or this type of map you can see. Okay. Then you can easily get. Basically this we can easily export. Suppose I create this type of map. This type of map I can export as a GeoTIFF file format. Okay, TIFF file format. So further, this GeoTIFF file format I cannot use directly in the my paper or presentation. So that's why I just use here the ArcMap or QGIS tool for creating the map layout, and then we are just using the research paper or presentation. Okay, so this is the JavaScript API code editor, but I want to use the Google Earth Engine using Python environment. So how I can connect the Python, okay, with my cloud? So this is my cloud project, Mijan 690. So this is my cloud project. So this cloud I need to connect with the Python environment. And why I need to use the Python? Because Python have a lot of powerful library. We can easily connect the pandas, matplotlib, then TensorFlow or Crush. Not only for the, it's provided a lot of library for the different purpose. We use the rasterio or different types of library we can easily get in the Python. And this type of library we can easily integrate with Google Earth Engine. Okay, and apply the different types of analysis. So that's why it's very important to use the Python and Google Earth Engine. So let's go try to show you that. So in this case, if you want, you can also use the Jupyter notebook, but Google Colab is more better because Google Colab is already installed at some library. Simply search Google Colab. So now you find out welcome to Colab. Just click on here. and click on the new notebook. Okay, so this is the notebook. Okay, so you can see this notebook is more complex, but previous time code editor, you can see this code editor is very rearranged. All of those we can easily get from this code editor, but this code editor is just only for the cell. Okay, we can also put the name. Suppose I put the name first day. So this is the code editor. There is nothing, just only for the cell. We are just make the environment of the Google Earth Engine. So when you import the Google Earth Engine, make the environment, first of all, you need to import some library, Python library. So one library is the GEmap. GEmap is one kind of Python library. The GEmap library, it's interacting with the Google Earth Engine, mainly connect the Google Earth Engine. As well as we also need to import another library. It's called the Earth Engine library, EE, Earth Engine library. Okay, so these two libraries need when you create the environment. I simply click to the run. And this type of library is already installed in Google Colab. Okay, so after that, just ee dot authenticate. Basically, it just simply check your verification, authenticate authorization using your Gmail. Okay, so in this time, this Google Colab, you try to open the same email. Which email you want to registration with the Google Earth Engine. Okay, try to keep the same email for authorization. Otherwise, it creates some problem. So in this case, my Google Colab Gmail and the registration Google Earth Engine email is the same. Okay, so then I simply click on the authenticate for authorization checking. So now it's click on the allow, and if you check, it show you your Gmail. Okay, so this Gmail I used for Google Earth Engine registration, and I keep the same email on the Google Colab. So just click on here and then continue. And if you check that, continue again. So now is authenticate is successfully done. It's working, yeah, done. So now ee dot initialize. In the initialize, if you we need to put the credential. So previous time it's not mandatory, but present time it must be mandatory. All of users, they must need the cloud project. You can see it show that no project found. So that's why we face this type of problem. So we need to define the cloud project, and where I can get the cloud project, we can get the cloud project from here. So this is my cloud project name. Okay, so without this cloud project, we cannot run the Google Earth Engine in the Python environment. Not only for that, I have also other, you can see this one cloud project, this is another, this is another, this is another, this is another. So I can use anyone, no problem, it will be work, no problem. So I want to use suppose this one. So just I simply define the project name. So just use the project equal, just a minute, project equal, put the project name Mizan e dot Mizan 690. We can put any name as the project. So this is my project name. I simply write and run the code again. So now it will be work. There is no problem. So only use this 3 line of code, then we can create the environment. So now this code editor is ready to use the Google Earth Engine. Okay, so now this code editor, I can easily apply any Google Earth Engine function. I can easily apply this type of Google Earth Engine function, basically this type of function. I can easily connect with the Google Earth Engine. I can easily import any kinds of data set from Google Earth Engine. So now this code editor is ready to use Google Earth Engine, but there is no map. You can see it's not showing any kinds of map, but it automatically show you the map. So we just simply add a map. So for that, just take a variable, suppose map. So I explain the later about what is the variable, how we can define the variable later. So just I take a variable, suppose map, and call the package. So this is my package. I just call and then use the map function. So from this package, I just call the map function. Okay, and these things, this whole things stored in this variable. Now run the code. Okay, it also worked. So now I want to display the map. So this whole things stored in this variable. I just copy the variable and paste and run. So now it will be added the map. So we find out this type of open state map in here. So this is the way we are just applying this type of environment we create and also add the map. Okay. So now we can easily add any kinds of analysis. We can easily add any kinds of satellite data or different types of GIS remote sensing application. We can easily do using this map. And now it's create the environment of the Google Earth engine. Okay. So I hope you can easily create the environment. It's not much difficult. Okay. Any
Sir,
question?
sorry for interruption.
Please, any question? Yeah.
Sir, why now we need Google Colab besides Google Earth Engine?
Okay, I'll explain about that. Just a minute. Okay. So just okay, this one. Okay, so now we talk about that Google Earth engine comparison between Python and JavaScript. So JavaScript, it provides you all of those we can easily get. Okay, and JavaScript API code editor is very powerful. Okay, any beginners, they can easily learn the Google Earth engine using the JavaScript API code editor. But Python code editor is not much good. It's just a cell. Okay, and we need to memorize all of those. So we can simply check the comparison. Python have a powerful code editor, and we can easily work with the powerful code editor. We can easily get all of those. We don't need to memorize anything. But when you work with more deeply analysis, then we just simply connect the Google Earth engine with Python, because Python have a lot of powerful library: TensorFlow, scikit-learn, pandas, then pytorch, numpy, then matplotlib, different types of library we can easily integrate with the Python and do lot of analysis. Okay, suppose I want to apply the deep learning. Okay, in the JavaScript API code editor, you cannot use the deep learning freely. But when you apply the Python library for the deep learning, we can easily connect the Google Earth engine and Python and apply the deep learning freely. Okay, but when we apply this code editor, we can just apply for the machine learning, and this type of machine learning built in machine learning. But in the Python, we can easily create our own machine learning method. Okay, and apply the Google Earth engine. Okay, so it's this the main region. It provides you a lot of powerful Python library. Okay, but Google Earth engine, this code editor give you the lot of opportunities. Suppose we can easily learn. We don't need to memorize anything. We can simply use this code editor, and we can easily create the different types of web application using this code editor. But Python, it have lot of library. This type of library we can easily use for the deeply analysis. Okay, for the deep learning or machine learning, we can easily create the different types of chart using the matplotlib, or we can easily apply the numpy, TensorFlow, cross, and more deep analysis we can easily do. So that is the region. In this session, I discuss about the both of Python and JavaScript. So then you can easily learn how we can easily use the Python and JavaScript at the same time. Okay, but we have another online training program. If you check it, okay, let me show you that. Just a minute. So we have another. This is the okay. You can see basically this is the deep learning Google Earth engine Python API for machine learning and deep learning. Okay, basically deep learning we can easily do using the Python library. Okay, that's why we are just make the another course content only for the deep learning. Suppose convolutional neural network. So this type of things we cannot apply in the Google Earth engine. This code editor is not apply. Okay, but we can also apply in the Python. Okay, connecting with the Google Earth engine, it also possible to use. Okay. Okay, so I think I got the idea about the comparison between the Python and JavaScript. But as the beginners, when you start the learning with Google Earth engine, first of all, we need to use this code editor. Okay, then move to the Python. Even Google Earth engine is also supported by R programming language, and R have lot of library or packages. So it also help you with the different types of analysis using the R. Okay. Okay, any question you can ask me, please. Okay, I hope there is no question. So let's go. Continue. So now we talk about, and I will send you all of practice code. So you also try to practice and also get the recorded session also. Okay. So let's go. Next slide. Open this one.